Hello friends, so let's continue with the second video which is on spherical coordinate system. So when we are learning electromagnetic field, we are dealing with the physical quantities which are vector quantities, and in some configuration, instead of using the conventional Cartesian XYZ coordinate system, it is advisable to use a different configuration. So in that connection, we had seen the cylindrical coordinate system in previous video. This video quickly describes spherical coordinate system, right? So let's continue. So a spherical coordinate system means that any point on a 3-dimension is assumed to be on a surface of a sphere. So a 3D sphere is assumed, and this 3D sphere is such that its center is at origin 0, 0, and this is the z-axis. This is x-axis with the conventional dimension. So the point P is over here. Now, how do you know? You know one dimension, that P is on the surface of a sphere. So its one dimension is equal to the radius of the surface, that is R. That is one part. So this is going to be the distance from the origin or radius of the sphere. So that is one dimension. Second dimension is going to be the angle this line is making with the z-axis, right? So let's say this angle is making angle theta. So that is second dimension. Now all set of points on the surface of sphere, these are the set of points which are making angle theta with respect to the z-axis. So this form, these different points, if you join with the origin, ultimately a 3D figure known as an inverted cone, you get it, right? So there are many points which are having angle theta. So this two not sufficient, third dimension is required. And this third dimension is nothing but, let us say that we drop a perpendicular on XY plane, and this is the line which is joining this point from origin. And let us see that it is making angle phi. So now, yes, now this point is unique. So this point is at a distance r. It is making angle theta with respect to positive x-axis, and it is making angle phi. It's perpendicular if you consider in this plane. Then it is making angle, this line is making angle phi with respect to positive x-axis. So r, theta, and phi are three coordinates of a spherical coordinate system, right? Now, look at this. What are this? This P is on the surface of this sphere. We have already seen that. P is at a distance r from the origin. P is at an angle theta from z-axis, and P is at an angle phi from the x-axis. The plane containing point P, right? So that is at an angle phi from it. This is what we have already showing this plane. Now, let's see the next part. This point is available in spherical coordinate system. Now, what are the dimensions? So this first dimension is radius. Radius of sphere can be any value from 0 to infinity. So R is nothing but a value which is greater than or equal to 0. Theta is what? Theta is this angle which is making with the positive x-axis, the z-axis, sorry. So it can make maximum 0 to 180 degree or pi, or 0 to, you can say, minus 180 degree or minus pi. So z can vary in this region only. And phi is the angle which is of this horizontal circle on XY plane. So it can vary from 0 to plus 360 degree or 0 to minus 360 degree, whichever way you note down. So these are the three ranges possible for r, theta, and phi. So r is a distance unit, theta and phi are angles. So they are either in degrees or in radians, right? Now let's see the conversion of r, theta, phi into x1, y1, z1. Suppose I have a point in a spherical coordinate system and I want to convert it into Cartesian coordinate system. So how do we do? So this is the r sine theta. This component is r sine theta, which is on xy plane. So if and this angle is phi, we already know that this dimension. So if I draw it on the xy plane, this part is shown over here. So this is r sine theta, this angle is phi. So this is cos component of it. That is x1 is r sine theta into cos phi. And this one is the opposite, that is y component of it. So y1, this distance is equal to sine component. So r sine theta sine phi. So very easily you can find out x1 from r theta and phi as r sine theta cos phi and y1 as r sine theta sine phi. And what is going to be this distance? So if you know radius and if you know theta, this is going to be the z cos theta. So z component is nothing but the r cos theta. Sorry, this distance is radius and this is its vertical, this component or cos component. So it is r cos theta. So if r theta and phi are known, you can find out x1, y1 and z1 as shown, right? Now next, let's see if x1, y1, z1 is known, and I would like to find out r theta and phi. How can I do that? So for that, so this is the point y1, this distance is y1, this distance is x1. So this line is going to be square root of x1 square minus y1 square. And this distance is already known. It is the z1 distance along z-axis. So r is going to be square root of this square plus this square. So that means using the Pythagoras, the r distance from x1, y1, z1 is nothing but square root of x1 square plus y1 square plus z1 square. Very easy. Now, as you already know that z is nothing but r cos theta. So theta is going to be, cos theta is going to be z by r, and r is already known. So here theta is cos inverse of z1 divided by square root of x1 square plus y1 square plus z1. This is z1. I hope you understand. One suffix is missed over here. And this angle is phi and x1, y1 are available. So phi is nothing but tan inverse of y1 by x1. So x1, y1, z1 coordinates are available. If suppose, then I can very easily find out r, theta, and phi as shown. So this is conversion from x, y, z coordinate to spherical coordinates. Now let's see the unit vectors. If this point is P on the surface of this sphere, then how are going to be the unit vector AR, A theta, and A phi? So you can see AR is acting in such a fashion that it is radially outwards. If I draw a line which is joining origin to the point P, and it is radially outwards in such a direction where radius is increasing and it is perpendicular to the surface of the sphere. So that is the dimension of AR. Now, what is A theta? So A theta is going to be acting in this direction. It is tangential to the surface of the sphere and in such a fashion that this theta is increasing. If suppose this line, if I would like to pull in this fashion, so this is the direction in which A theta is there. In A phi, as usual, this is the point, right? XY plane is showing this line. So this is the dimension along which the phi dimension is increasing. So it is going to act in this fashion. And it's a 3D figure. So I hope to visualize that AR, A phi, and A theta, all these are mutually, that means perpendicular to one another, right? So AR is radially outwards, perpendicular to the sphere. A phi is tangent to sphere along XY plane such that phi is increasing. And A theta is perpendicular to AR and A phi. It is tangent to sphere such that theta is increasing, right? So this is all about the spherical coordinate system. We have seen what are spherical coordinates. We have seen how to convert from x, y, z to r, theta, phi, or the other way, and what are the unit vectors, or in which dimension, which direction the unit vectors are there in the spherical coordinate system, right? So that's all in this short video. We'll continue with more such videos of this subject in our subsequent videos.